Sumpner's test. Sumpner's test is one of the important tests which is performed in electrical machinery lab. Usually we have a circuit diagram, and from this circuit diagram we have to make physical connections and perform this test. So in this particular video we are going to find how to make connections in the electrical machine laboratory for Sumpner's test. So we are having circuit diagram for Sumpner's test. From this particular diagram we are going to determine the instruments required for this test. We could see there are two transformer. Identical transformer is needed. Single phase transformer is needed for performing this test. So the rating is mentioned in this particular test. Then we need two auto transformers for supplying the circuit. There are two wattmeters, two ammeters, one voltmeter, one switch. Then there is need of another voltmeter to measure the supply voltage. We can use, instead of voltmeter, a multimeter could be used, and connecting wires are needed. So these are the instruments, the physical instruments which would be available in your electrical machine lab. This is auto transformer, single phase auto transformer. This one is your wattmeter, single phase transformers, a switch, ammeter, voltmeter, multimeter, connecting wires. Please note that all the measuring instruments that should be AC, because transformer works on AC. So let us begin how we can make physical connections using circuit diagram. So what we are going to do, first we are going to divide this circuit into two parts. Depending upon, you could divide considering your convenience. I have considered this portion of circuit first, and later on I am going to consider this portion. So for our convenience I have zoomed out, and we can see that this is showing auto transformer and this one is showing wattmeter. So first of all we are going to connect auto transformer with the main supply, and then this auto transformer will be connected to the wattmeter. So these instruments are shown here. So let us begin with auto transformer. This particular cord which is showing which is shown here, it will be connected to the main supply. Usually it comes with a plug. That plug can be put it on socket, 16 ampere socket. So this connection is quite easy. Then these two terminals, that is indicating the transformers two winding, basically the two terminals that is shown here. So these two terminals are indicated here. Then there is a wattmeter. So here is the wattmeter. We have wattmeter, and you could see there are some letters are written over here, M, L, C, V. So we have to first locate these letters on the wattmeter. So let us find these letters on wattmeter. You could see that this M is written over here, so this knob is indicating M. The L is indicated here. Then we can see the C is the common terminal, which is C is called as common, so it is located here, and here is the V. So in V we could see that there are three terminals. So what exactly it is indicating? So here a figure is a picture from top view is shown here, and we could see that it is written 150 300 and 600 volt basically. So what exactly it is indicating? It is indicating that this particular wattmeter could be utilized at different voltages. If you notice, you are going to find out that the wattmeter which is required for this particular test is 150 volt 5 ampere. So we have to utilize this 150 volt knob for this particular purpose. If the 300 volt is needed, we could utilize 300 volt, and 600 volt if needed, then 600 volt would be utilized. The another thing we could note it here, that this particular wattmeter should be able to carry 5 ampere current. So how to find out that 5 ampere current? So you are going to find out that these four terminals are there. So basically these four terminals are going to decide the current. Basically these four terminals could be connected in two fashion. One fashion is here shown, that the strip is connected horizontally. The another fashion is that where the strips are connected vertically. So basically in these two fashions the strip could be connected, and this is indicating that the range of this wattmeter. So how we are going to find out which what is the range, what basically when it is connected horizontally, so what would be current it would be carrying, the wattmeter would be carrying. So usually the wattmeter comes with a manual, so you can go look into the manual. Otherwise usually there is a sticker which is pasted on bottom of the wattmeter or in the cover of the wattmeter. So you are going to find out. So here you'll find out that when the terminal B1 and B2 is connected together, that is these two terminals are connected together horizontally, then it will allow to carry the current of 5 ampere. These strips are designed in such a way that you could only connect horizontally in this way only. Only terminal B1 and B2 would be connected together horizontally. The strips is making it's horizontal. The another combination that is horizontal is, so it is mentioned there, B1 and E2 that is connected together. So B1 and E2 when it is connected together, and E1 B2 it is connected together, so it is going to give a 10 ampere range. So this vertical connection is giving you 10 ampere range. Another thing you should notice, you should note that whenever you are going to record the reading from this wattmeter, it must multiply by a multiplying factor. So you are going to find out the information regarding the multiplying factor depending upon what voltage and what current you are considering. The multiplying factor would be can be determined. So you could see in this chart that for 5 ampere for 150 volt multiplying factor would be 1, 5 ampere 300 volt multiplying factor would be 2, 600 5 ampere 600 volt multiplying factor would be 4. Similarly you can see for 10 ampere 150 volt it is 2, 10 ampere 300 volt it is 4, and 10 ampere 600 volt it is 8. So it is usually a multiplying factor can be determined from this particular chart. So let us connect this wattmeter with auto transformer. So we have seen that one of the terminal which is coming from auto transformer is connected to the M terminal of or M knob of wattmeter. So we have taken one wire and which is connected to the one terminal of auto transformer, and then the another end is connected to the M point. And you could see there is a coil between M and L. So basically this is a current coil and which is inside this wattmeter. So you not need to worried about this coil which is shown here. Basically this coil is inside this wattmeter and it is connected between M and L. So what you have to do, you have to connect this L. A wire has to be connected from L and then it will be connected further. So what we have done, we have taken a blue wire and that is connected to the L, and now it is left open because we are going to further connect it to another instrument. Then we can see here is a C terminal, so C is common terminal, and M and C is connected together in this circuit diagram. So there is no internal connection between M and C, so we have to take another wire and we have to short M and C. So here the yellow wire is taken and it is connected, one end is connected to M, another end is connected to the common terminal, so it is basically short circuiting. Now we can see between C and V there is a coil is there. So this particular coil is a voltage coil. Again, you not need to worried about this coil. This is internally connected within the wattmeter. So you have to connect this V terminal and it is connected with the second terminal of your auto transformer. So we have taken a wire which is one end is connected here V and the another end is connected to the second terminal of auto transformer. Please note that the rating is given here 150 volts, then therefore the 150 volt knob is selected here. So you need to connect here the other two terminals that has to be left open. Then let us move on. So what till time we have connected this much connection has been done. Your auto transformer is connected to the supply, then the auto transformer is connected with the wattmeter. The other thing that you should note that it is 5 ampere, so 5 ampere connection you have to make it. Now let us move on. The another element is here ammeter, and so this ammeter is there. Again we could see there are a number of terminals, so let us see what are these terminals. You are going to find out at one end it is written in one of the knob or terminal it is written the common, and then 10, 3 and 1 ampere is written. Again it means this is a multi-range AC ammeter, so it could be utilized for measuring 10 ampere current up to 10 ampere from 1 ampere. So different ranges are there. We required a 0 to 1 ampere range. It means we have to utilize the common terminal and 1 ampere terminal. So let us connect it with the wattmeter. So we can see that the terminal which is coming from L is connected to the common terminal or one of the terminal of ammeter. You not need to worried about whether you are connecting to this or connecting to common terminal or connecting to the 10 ampere 1 ampere terminal, because if suppose the direction of current is reversed through the ammeter, so the deflection would be reversed. So you not need to worried about if the deflection while switching on, if deflection is on negative side, so you can reverse the connection. So usual practice is to connect it to the common terminal. So this was earlier diagram. The left terminal which is coming from the L was left kept left open. So now this terminal would be connected to the common terminal. Another wire is taken out from the 1 ampere terminal. So till this point we have completed the connection. After this we can see that there is a transformer. This is the transformer, and the transformer has two winding. Usually we call it as primary or secondary, but as such in this particular transformer you are not going to get the primary or secondary winding. So this transformer rating is 115 oblique 230 volt 1 kVA transformer. So this particular side is called as the LV side and this will be the HV side. So in transformer you have to first find out the LV side and HV side, and both winding will be having two ends. One would be the starting end and another would be the end. So you are going to find out there are two ends here. Here LV is written, so this is your LV winding and this is your HV winding and corresponding terminals. So basically this 1 and 2, that is indicating these two ends. You can mark anyone as 1 and 2. So the two ends are shown here for LV side, and similarly you are having two terminals for HV side. So once it is marked, you would be in position to connect it to into the circuit. So this, let us connect this transformer to the circuit. So this was the previous circuit where we left one wire open. So we could see in this circuit diagram that one end is the ammeters one end is connected to the one end of LV of first transformer. So here is your LV, and this one is if your first terminal, so just connect that left open which was left open, so connect it to the first terminal. Then you could see that the another terminal which is connected to the second terminal of the supply. So you can take a wire from this terminal and it can be connected directly to here. Otherwise you can see here that this terminal is also connecting with the V of wattmeter. So you can connect it to the voltage terminal of the wattmeter. So we have connected this terminal to voltage terminal, and then voltage terminal is connected to the second terminal of auto transformer. So there are two ways. You are having two choice. Either you can connect it directly here, or this could be connected here. So till time we have made completed these connections which is shown in this figure. Let us move on. Now you could see that there is another transformer. So we are having two transformer and their LVs are connected together. Basically these are connected in parallelly. So what you could see or observe here, first of all you could mark LV's first terminal, second terminal. For first transformer, for second transformer, LV could be again marked the first terminal and second terminal. So basically the first terminal of LV of first transformer is connected with the first terminal of LV of second transformer, and the second terminal is connected with the second terminal. So what you need to do, just in second transformer you need to identify which one is the 115 volt LV side and which one is the 230 volt HV side. So the LV side is connected together, the two terminals, the one is connected with 1 and 2 is connected with the 2. It's just you need to keep it in mind which one is the 1 and 2. So till time we have completed this circuit, this side circuit has been completed. So that is shown here, that part is completed. Now we are going to consider this particular circuit, this part of the circuit, and we are going to connect on the similar line. So you could start with from any side, either from the transformer side, or you can start from the supply side. So for my convenience, I am going to connect this circuit. I'll start with this side basically. So let us consider on the same line we are having auto transformer. This is the second auto transformer, second ammeter and second wattmeter that is connected here. So one of the terminal we could see that is connected with the ammeter. So just take one wire, connect to one end here, the another end could be connected to the common edge. Already I told you it's okay if you are connecting this to common, or this terminal to the common terminal. The later on you can find out whether depending upon the deflection whether you have connected it properly or not. So it could be reverse. So we have connected one of the terminal to the common, and another terminal that would be connected to the L terminal. So from here this knob we have connected to the this terminal. What you have to keep it in mind that this ammeter range is 10 ampere. So this is a multi-range ammeter. You should note that it should be properly connected with the 10 ampere knob. So we have taken out this wire from the 10 ampere knob and further connected to the L. Now there is M which is connected to the switch. So take one wire from the M and that will be connected to the switch. M and C is short circuited, so we have taken a wire and M and C is short circuited. Then we can see from this switch one of the wire is connected to the transformer, so one wire is taken out and it is left open. And from V it is connected to the second terminal of the supply, which is not connected in this particular diagram. You can connect it to the second terminal of the supply. It could be connected, or it can also connect it here. So depending upon the choice, your convenience, you could connect it here. So we have completed this side. This much connection has been completed, except V is not connected here. You not need to bother about these two coils. These two coils are the current coil and the voltage coil that is inside the wattmeter. It is already connected, so terminals are shown there basically. So here let us further move on. What you could see that this V is till this was the previous circuit, we have left it here. So this particular after this switch that has to be connected to the transformers, first transformer, second terminal. So here what I have done, rather connecting to this point, I have connected this particular circuit at this point. So I have connected this wire to the second transformers, this terminal basically. So it is not connected here. I have connected this particularly here. So later on again, while you are going to check basically these HVs are basically connected in series phase opposition. So in order to check, you are going to use a voltmeter. So we have not connected a voltmeter across the switch. You can connect a voltmeter across the switch, or you can use a multimeter to measure the voltage to find out whether the transformers are connected in phase opposition, series phase opposition or not. So timing this circuit, I'm not following this particular side of the circuit. Here I have connected the switch. So complete setup is reversed, so it is connected here. Now what is remaining in this particular circuit, that is the HV's connection. So what you could see that the HV's first terminal is connected with the first, and the second terminal which is connected of first transformer HV winding, that is connected with instrument. So just I have replaced here. So what you have to do, this first terminal has to be connected with the first terminal. So this terminal is left open, and here you could see that here it was left open. So this is left open and this is left open. So we have to connect it with a wire. So that has been connected basically. Now this particular please note that I have connected this one is connected with this one, but just this is connected here. So that changes has been done. So once you are going to perform this test, when you are going to follow the procedure, you must find out the voltage across this switch. Actually it should be 0. If it is not coming 0, it means the circuit is not connected parallelly. So still we are having one uh, point is left here, that is we have not connected this V, and the second point of the second terminal, the second supply side with the transformer winding, so that is still left open. So we are going to connect this particular uh, uh, line, and this V that would be connected with the second terminal. So you could see that one wire is coming out from here, which is connected to the V terminal, and from V it is given to here. So this is showing you a complete circuit here with a minor change in this particular circuit that is shown here. You can just reverse the connection. Rather connecting here, you can connect this terminal on this side, and this would be connected, then this would be fine. This wire would be connected only here, so that interchange could be done. So this is the complete circuit. We have connected the physical connection of the instrument, which is showing here. So this is a complete diagram. The voltmeter, regarding already I have shared that this is not connected here. You can connect a voltmeter across this particular terminals, and or you can use a multimeter, and which could perform as a voltmeter. So that is an important thing. This is a complete circuit diagram, our connections, what we have made it. One another way you could connect this particular circuit, here two circuits are shown. You could see the switch is kept it here or here. Basically what we have done here, the position of the switch is rather keeping it here, it is placed here. So that could be also made. So you can basically change the position of the switch, ammeter, and the watt meter, so the position could be changed here as well as here. So here we have changed the position that is shown here for your uh, better understanding. So it's fine, sometimes it is not necessary that you follow the circuit like I have not done here. So you could place the switch position. This is a larger picture of Sumpner's test. In this video, just the intention was to how to make connections in the lab. Please note that do not switch on the circuit without the inspection from your lab instructor, technician, lab technicians, lab assistant, or the faculty members, because in this particular video no procedure has been uh, uh, shared with you. How this test is particularly you are going to perform, that is not shared. The only purpose of this video was to how you are going to make connections using the given circuit. So this must be verified. This is a message to you that do not switch on. It could be quite dangerous, because if your secondaries, that is your HV side, which is connected in series, it should be series phase or position. If it is not there, it could be dangerous. It may damage your equipment, or it could be more severe than that one. So please do not switch on. Just verify the connections from your lab assistant, technicians, faculty members. On their approval only switch on and follow the procedure of this one. There is another video, you could find the link in description, how you are going to perform this particular test in your lab. Thank you very much for watching this video and understanding for making concept. Thanks a lot.